Okay, so we'll solve this question, find all the lonely nodes. In a binary tree, a lonely node is a node that is the only child of its parent node. The root of the tree is not a lonely node because it does not have a parent node. Okay. Given the root of binary tree, return an array containing the values of all lonely nodes in the tree. Return the list in any order. Okay. So let's analyze this question. Okay, so here 4 is a lonely node. But when I am at 4, can I know that 4 is a lonely node? Actually, no, because I cannot know whether there is any other adjacent value or not, right? So what I could do is when I'm at 2, when I'm at a node, I could check its children. So let's say 4 does not has a sibling, right, or does not has an immediate left node, so 4 is lonely. So what I'll do, I'll simply check whether a node has only one children, and if there is only one children, then add it to list. Okay, so let's solve this. I'll take an integer list. I'll say it list is equals to new array list. Okay, then I'll create a helper function. Now I'm assuming that this helper function would take in a root node, take in a list, and at the end I'll in this list all the data would be there, right? All the nodes, all the lonely nodes would be there. So what I would do is I need a void helper method. It could be private, right? Yeah. Then I'll say tree node root and a list of integers. Now I'll say if root is equal to null, return. We don't care anything about this, right? Now I'll say if root dot left is equal null and root dot right is not equals to null. That means the right one is our lonely node, right? So I'll say list dot add root dot right dot value, and then I'll do the same for the left side. I'll say if left is not equals to null and right is equals to null, then this, right? And then I'll traverse the whole tree. I'll say helper root dot left list and helper root dot right and list. So let's try to run this. Okay, it is working. So let's analyze what we have done again. We have taken a list, we have sent this list into a helper function, right? So now if the if the node is null, so let's suppose after 4's this side or right side they would be null. I don't want to do anything to them, right? So I'll simply return. Then I'll say if I'm at 2 and if the left node is null but the right node is not null, so I'll put the value in the in the list, right? And similarly if a node is there and its right side is missing but left side is there, so I'll put its left side in the node in the list, and then I'll traverse the whole tree, right? So let's try this. Let's submit it. Okay,